Another 2 minutes will start. 8595 will start. Previous class is over or not?
Sir, just attendance is going on.
Okay, no. Once it will over, you tell me.
Excuse me, sir.
Yes, please.
Sir, वो XV6 install नहीं हो रहा है.
Yeah, I update one more file in the module. You just download that one. Now it is working in my machine also. Previously, 64-bit it was not running. Now whatever I have uploaded, it is running fine.
Okay, sir.
sir.
Yeah.
सर ये init process का parent ID 612 क्यों डिस्प्ले कर रहा है?
Init process का 1 का?
Yes sir.
कहाँ पर?
सर वो जो मतलब p टेबल
Yes,
का पेरेंट को रेफरेंस करके उसका आईडी प्रिंट कर रहे हैं तो वो डिस्प्ले कर रहा है 612 XV6 में.
XV6 में?
यस सर.
1 नहीं ले रहा है उसका?
सर वो तो उसका PID 1 ले रहा है पर पेरेंट आईडी उसका 612 आ रहा है.
मतलब 1 का पेरेंट आईडी?
यस सर.
ये एक गार्बेज होगा इसलिए. You don't worry about that.
Okay, okay.
Because he is not considering that one. It is a small one, no? That's the reason. Oh, that we are asking. So once init process is parent, that will be considered as garbage there. They are not considering at all. Uska koi parent hoga बोल. Are you getting
Okay,
it?
sir. Okay.
That's the reason. Okay, it is now 5. We'll start. Huh? Otherwise, we cannot complete the course. So last class, I hope you have practiced the programs. If you have not done one more class, we'll do it because that is very, as per your exam is concerned, and that part was very important. And next thing, little theoretical today. Huh? So please concentrate, but very, very important. So we have studied the FCFS, SJF, and SJF's preemption, non-preemption, and priorities preemption and non-preemption. We have studied the preemption one. I hope the non-preemption what to do you know. Huh? Then we have studied the round robin. So all this algorithm, if you can look into it, these algorithms such a specific purpose. Means for a different kind of job, the different types of operating system algorithm, scheduling algorithm is preferable. Like if you can go for round robin case, yes, in the round robin mostly use your interactive processes. Means where the response time is very good in case of round robin. But if you go for the waiting time is too high in case of response round robin, because we have studied that if every job will be partially executed 2 minutes, 2 minutes, 2 minutes like this, at the end all the jobs is going to be completed. Means everybody has to wait for a long period of time where the waiting time will be more. And this kind of where the waiting time will be more may not be suitable. This is not suitable for like heavyweight jobs. For heavyweight jobs, not suitable. Then which one is suitable? For this heavyweight job, we prefer this FCFS. Means FCFS is mostly suitable for the non-interactive processes. You can say, sir, non-interactive processes. Another we have studied, that is SJF. Yes, that is also fine. Since SJF is not practically possible, we prefer the FCFS and do these things. And if you can go for the round robin, this round robin is basically the combination of FCFS plus preemption. if you can clearly look into it, that it follows the FCFS because it is maintaining a queue. Your RR is maintaining a queue. The way the persons are coming inside the queue, in that way they are executing. But the only thing he is adding a new features with this FCFS is the preemption. So he is preempting after 2 units of time and again try to join the process at the end. So your round robin basically preferring interactive processes. Your FCFS is basically preferring the non-interactive process. And along with this, there is one more thing comes into picture, that is a priority. And priority will be preferable because the jobs are of different types. Somebody may needs immediately with a high priority. That time you cannot say that no, I am running a round robin or I am running this particular FCFS. I cannot allow you to execute. Like you are running the programs and immediately a mouse is moving. So mouse movement is an interrupt. For that interrupt, one process has to be executed. You will say that no, my round robin is running. In the queue, there is 10 processes are present. If each process requires 2 quantum unit, after 20 units of time, your mouse is going to be moved. Then nobody likes this kind of mouse. I move the mouse, but it is moving, it is showing in the screen, the cursor is moving after 20 milliseconds or 20 units of time. Nobody likes this. So that's why the priority also plays an important role. So if you combine this one, combine this one, combine this one, these 3 algorithms plays in different role at a different time. Now the question comes, your system is a combination of different kinds of jobs. So when you run a system, you cannot say that all the jobs are interactive. May not be. All the jobs are non-interactive, very heavyweight. May not be. All the jobs may not require any priority kind of things. Then can you design an algorithm which will be combining these 3 things? Are you getting the requirement? Because whatever the algorithm we have studied now, each algorithm has a specific purpose. So round robin is specifically for the interactive jobs, where if it is a big job and you apply the round robin, it may not perform well, because as you have studied, your waiting time is too high. If waiting time will be too high, 1000 units jobs are coming. That is a 3000 unit jobs. And you find that all 3 jobs, 1000 each will be completed at the end. That is at 3000 units of time, your 3 jobs gets completed. Nobody likes this kind of things, even if your round robin is quite good. Yes. So similarly, if it is interactive, but you are using FCFS, then it is not good. Similarly, I want a priority. I want to move the mouse. My mouse cursor has to be immediately displayed, because there the priority plays important role. Even if round robin cannot work, your FCFS cannot work. Your priority has to be plays an important role there. So 3 things has to be combined together, and you have to design one algorithm. Then what they thought, why don't you design a new algorithm that is a multi-level queue scheduling? Multi-level queue scheduling. So what this multi-level queue scheduling basically says that it will design the ready queue into different queues. Okay, consider that this is your Q1, this is Q2, and this is Q3. All these queue are for a different kind of job. Let's take it is for the system processes. Let's take this is for the interactive processes. Yes, processes. And let's take this is for the non-interactive processes. And what he does, for every queue, he is performing a different scheduling algorithm. Different scheduling algorithm for each queue. Yes, since you are performing here interactive jobs, so all interactive jobs will be joined in this queue. All system processes jobs will be joined in this queue, and all non-interactive heavyweight jobs will be joined in this queue. And this particular queue may perform one kind of a priority algorithm. This may perform a round robin algorithm. This may perform another, let's assume that it is a FCFS algorithm. So what you happen, instead of making a single ready queue, this ready queue is now separated into 3 sub ready queues, and each ready queue has a specific purpose. The first ready queue may only accept the system processes, next will be the interactive, next will be the non-interactive jobs. And each, since there is a different kind of processes present in different queues, so different queues follow the different scheduling algorithm. And these 3 are basically given to the CPU. Yes, now the question arises, sir, how these processes inside this they will be executed? It's okay. It is following one priority algorithm, it is following one round robin, it is following the FCFS, but my CPU is 1. So how it is going to be executed? So what they thought, why don't you apply a priority to each queue? Suppose its priority will be 1, its priority will be 2, and its priority will be 3. So they are saying the processes, those who are present in this queue, first they will complete, then it will come here, and then it will come here. This is one kind of approach. Another kind of approach, maybe in this way, that thing, why don't you keep a quantum time here? So Qt is 10, here also Qt is 10, and here also Qt is 10. Means the 3 queues are applied with a round robin algorithm. So you are giving 10 units of time to this queue. Whatever the processes present inside the queue, they will be maximum executed for 10 units. I mean, not each. Suppose there are many processes present here. He requires 2 units, he requires 3 units, he requires 6 units, like this are there. So first this will be executed, this will be executed, this is partially executed. Because total I am giving it 10 units for the whole queue. Then 2 plus 3, 5, and it will be partially executed 5 minutes. Still 1 unit of job is left out, and immediately your CPU moves to this place. After spending 10 units of time, again it will be moved to this place. So like this it is going on in the snap. So this is one approach that is called as a multi-level queue scheduling, where different kinds of job are followed by a different kind of algorithm which is preferable for those kind of jobs. But here some disadvantage is there. The disadvantage is that, let's take you are applying the priority. If you apply the priority, unless until all these jobs of the first queue gets completed, the process cannot come here. Means even if the process with a heavy weight comes to this place, still he will be starved for a long period of time. Why? He has initially comes, but later on many processes continuously coming for this queue and this queue. So he never get a chance to be executed. So what's the difficulties in this multi-level queue scheduling is that there is no movement of processes from one queue to the other. No movement of processes. Movement of processes from one queue to another. One queue to another. So that's why this particular multi-level queue may not be suitable for a real environment. It may be identical with respect, it may be good with respect to all kinds of jobs are combined together and a different type of job following the different kinds of processes. Yes. Yes, are you asking something? Hello? Are you getting the things or not?
Sir,
Hmm.
sir, but here in this multi-level queue, another disadvantage could be that that scheduling algorithm is taking a longer time. Too much
No.
work to do.
Anywhere you put the scheduling algorithm has to be take a time. The scheduling algorithm taking longer time may not be a good answer for this. The reason is that even if it is you are not following this multi-level queues, only single queue, there also a scheduling algorithm has to be preferred. Either round robin or whatever may be, that has to be preferred. So there is no question behind this, the scheduling algorithm takes more time. But my point, yes? So that is not an issue. So what is the requirement now? The requirement is that I prefer this queue, but along with this queue, can the processes will be moved from one queue to the another queue? then it will be a better approach. So I followed the different types of processes. I followed the different kind of scheduling algorithm. At the same time, nobody is going to be starved for a long period of time, because there is a chances of a movement of processes from one queue to the another queue. So that is the requirement. So that requirement is fulfilled by another algorithm called as multi-level feedback queue. Multi-level feedback queue. Very, very powerful and usually used also in the real environment. Let's just look into it, how it is happening. So in the multi-level feedback queue, here also there is a different queues. Yes, there are different queues. Each queue has a certain priority. Yes, so this is the priority 1, this is the priority 2, and this is the priority 3, and this is the priority 4. And this priority will be high, and this becomes the low. Yes, and each queue is following the only one type of algorithm is called as the round robin. Yes, this is also following round robin. This is also following round robin. Each one of them are following this round robin algorithm. Yes, so first rule he is saying he has designed the number of queues. The number of queues he has just prepared. Let's take there are 4 queues. And here the priority is the first queue is the higher priority and the last queue is the lowest priority. And every process are using a round robin algorithm. But even if it is following the round robin algorithm, here the quantum time little varies. So the quantum time, let's assume that it is 2, QT here is 4, QT here is 6, and QT here is 8. Means as you go down and down, you can think about your quantum time that's gradually increasing. Means this kind of a queue is mostly suitable for the FCFS. Why it is like this? Let's assume that I followed a round robin, but the quantum time is too high. It is equivalent to FCFS or not? Are you getting my point? If I follow a round robin, and in the round robin algorithm, my QT is 2000 minutes, then in that case, it is equivalent to, it is an FCFS algorithm. In the same manner, is saying, initially, the queue's quantum time is 2, and gradually this quantum time gets increases. That is, first, it is ready. Then what's the principle? The principle is always the higher priority job will be executed first. So first principle, higher priority jobs will execute first. Will execute first. How it is happening? He's saying when a jobs are coming, as per the previous example, the jobs are distributed among these 3 queues. But here it is saying it is not like that. Every jobs comes, it will be entered into this queue. This is only the entry section. Yes, the jobs are first time entering into this queue. Yes, then how it is executed then? Since it is a round robin fashion, it has to be executed for, suppose the round robin is 2 units, 2 units, 2 units, 2 units, 2 units like this. Then how, what about this queue? He is saying if a job is completed, not completed, if a job is completed, it's okay. If the job is not completed within 2 units of time, then it has to be go down to the next queue. What's the process? Please remember, if a process is not completed within its quantum time in that queue, then it has to go down. It is going. Then when it will stay here, suppose the quantum time is 2 units. Before these 2 units, the job requires any IO operation or something, then that process has to be stay in the same queue. Please remember 2 things. What I told, every process comes here, enter into the first queue. That is the first thing. The second is saying, after it will start executing in the first queue, because always the CPU has to be executed first queue. Unless until this queue becomes empty, the CPU cannot come to this place. Again, this will not empty, the CPU cannot come to this place. Means CPU always prefer this queue first. But what happens? If a process is not completed within its quantum time, then it has to be come down. That is the first thing. Second thing is saying, if during this 2 units of time, because I have given the 2 units of time to execute to a process, if during this 2 units, before the 2 units of time it is left for some IO, then again it has to be joined in the same queue. Understood? Yes? Then how it is happening then? Suppose a process requires 1 unit first for the CPU and then again 3 units for IO. Then what happens? I have given here 2 units, 2 quantum time. After 1 unit of time, this process again join in the same queue rather than it is going down. Suppose I have given first the 3 units for the CPU execution for this job. Then after 2 units of time, it has not completed because it is required 3 units. So immediately it will be come down to this place. And next process which is present here, it will be going to be executed. Now you can argue. So how it is satisfying the whole algorithm? This is only this much. The only 3 things I told. It is set the priority for each queue. It set the quantum time for each queue. It is following the round robin in each individual queues. And every process when they will enter into the first queue one. And what is the process of execution? Unless until the upper queue gets completed, all the processes are completed in the upper queue, the CPU cannot move to the lower queues. Okay. So how it is happening? Then when the process is executed in any queue, then that process may stay there in the same queue or may go down to its lower priority depending upon the 2 choices. One choice is that if he could not complete within its quantum time, then it has to be come down. Means he feels that it is a larger size job, better to execute it in a lower queues, because lower queues are mostly suitable for FCFSs. So that's why it is better to execute it in a lower queue. But if the job is more interactive means what? I have given 2 quantum time, but before this 2 quantum time, the job itself wants some IO operation, means wants to interact with the user. In that scenario, what is saying? Why don't you bring the same job after the completion of IO to the same queue? So that what happens? It is acted as interactive so that it will be executed in the first queue itself. But if any job is little heavy, bring it down. If it is too heavy, bring it down. So like this it is happening. So by this, you can see I am achieving the round robin, I am achieving the FCFS, I am achieving also the shortest job first. Now the question, how is the shortest job first is executed here? Okay, round robin, I am following in every queue. FCFS, I told that if it could not able to complete it within 2 units of time, it has to be come down where the quantum time is 4. If no jobs present here, then the CPU executed here and he is giving 4 units of time. And during 4 units of time, that job is also not completed. Then bring it down. So at last it will come here. Means you can say it will be bring it to this place, it will be bring it to this place, it will be bring it to this place. But what about this last? Then what happens? All the processes will be, if it is a heavy jobs, then heavy jobs will be come down at certain stage, they will become here. Once the jobs will become to this last queue, then after, let's take more jobs are coming for this first one. Then what happens? Then the same stagnation comes like I showed in the upper case, because the processes, those who are present in the last queue, they may not get a chance to be executed by the CPU because larger number of jobs are entering into the first queues. So it may happen in the same manner. If a job has come, it tried to execute here, it could not complete, come down, it could not complete, come down. So at last it will come here. There may be many jobs are present in this last queue, those who are very heavyweight jobs. After they are coming here, then more number of jobs are coming to this queue, which requires very less unit of time. Then the CPU never moves to this lower queues. Then these people are mostly in the star. When the same problem comes into picture, what's the benefit? Then what that rule? They apply another rule. What is this rule? It will fix a fixed amount of time. After that fixed amount of time, every job present in all this lower queue will be moved to the upper. How beautiful he has designed this algorithm. What is saying? Suppose you will fix a 50 units of time. After 50 units of time, wherever you may be, you will come to this beginning of it. So that again, the operating system give you a chance to be executed if you are becoming a heavyweight also. Because even if you come to this place, still the operating system give you a chance to, why don't you execute it in this queue? Let it be, you will get a chance so that you will never feel that I am start. But again, you are too heavy. If you are too heavy, again you come down, come to the last queue, where again the XCFS has to be followed. Means the operating system give a chance, because of your heaviness, you come to the lower queues. But operating system is giving this chance. Okay, this is the second thing. The third thing,
Sir, you told that after a fixed amount of time, it is getting promoted to the above queue.
it will all this queue's job, this queue's job, this queue's job, join in this queue.
So means that it will go directly to the first queue.
It will go directly to the first queue.
Okay, sir.
Okay, it will go directly to the first queue. That is one. Then another interesting part, if you will observe this, suppose let's take, I have given how a process will be stay in the same queue. What rule I told? How a process will not come down to the next queue?
If it requires any IO
IO.
operation.
Yes,
Within
hence,
queue.
before the quantum time, a process will be moved for some IO. So that we can understand that it is very more interactive. Yes or no? Because I give you a 2 units of time, but after 1 unit of time, you told that I have to get some data from the user. Then you have to go for the IO. Means you are not wasting the CPU time more and more. Then you are more interactive. If you are more interactive, better to stay in the same queue. Yes or no? That is one. But what is saying, since the programmer may be very clever, what the programmer will be clever, he will say, he will write the program in such a manner that after every 2 lines, he needs a simple one yield statement. There is one yield function is there, which will say that I will go for some IO or return kind of statement. So if he knowingly put some yield statement, and this yield statement says that after 1.5 unit of time, I will return to this IO. Then again after 2 lines, I will return to this IO. Then what happens? Even if it is a very big job, heavy jobs, but knowingly this programmer has designed this job in such a manner that he always try to stay in the same queue. He does not have to come down, because just before 2 units of time, he called this yield. Just before 2 units of time, he called this yield, because he is very clever. So it is creating a problem. So what happens? Knowingly, a process, even if it is heavyweight, he is not coming down. If it is not coming down, then he is occupying a non-interactive jobs will be occupying in the first queue. Then interactive jobs will be somewhere. Then what? Another rule is saying. Another rule is saying, even if he is clever, he is saying that in this multi-level queue, there is another fixed unit of time they have fixed. Suppose it is a 20 units of time. Means after 20 units of time, even if you are entering, again going for IO, entering, going for IO, after exactly 20 units of time you stay in this queue, definitely you have to come down. Are you getting what he's saying? He's saying, even if suppose he has applied, after 1.5, no, he return a yield. After 1.5, he return a yield. Suppose he has fixed at 10 units. Means after 1.5, 1.5, 1.5, like 6 times, 7 times, guaranteed that job has to be come down. एक बार नीचे आ गया तो ऊपर जाने के लिए क्या चाहिए? You need this quantum time. Yes or no?
Promotion.
Yes. Again?
Sir.
Yes. Hello.
Nothing, sir, nothing.
Yes, any doubt or I'll continue?
Sir,
Hmm.
sir, if the process didn't require IO operation, then also it has to go.
Oh, yes, no. If a process does not require any IO operation, then after 2 units of time it will not complete. Can it complete its work after 2 units of time? No, no. So it has to. That you have already done. That you have already. As I have told in the last example, last class example, you don't know. Some require CPU, then some IO, then some CPU. Suppose here the process P1 requires a CPU of 3 units, then some IO work, then some 4 units of work. So CPU process first enter into here. He needs 3 units, but after 2 units, the quantum time over. Since you could not complete your work within 2 units of time, you have to come down. Okay, but here what I told here, I told here specifically that if knowingly somebody knows that he is using this multi-level queue and he is using some 2 units, 4 units, 6 units and 8 units of quantum time. So knowingly what he does, after very few lines, he written one eld. After very few lines, he has written one eld. Means cleverly what he does, after 1.9 seconds, he wants one IO. मैं बाथरूम जाना चाहता हूँ, फिर थोड़ी देर बाद फिर एंटर करेगा, बिकॉज वो कंप्लीट नहीं हुआ. 2 घंटे से 2 मिनट से पहले ही वो बोल दिया कि मुझे IO चाहिए. Again, operating system could not know about these things. Again, he allow him to enter into the same queue after he come back from this toilet. Then once it will come here, again what he does, he is very clever. After 1.98 second, he told that I want again for the toilet. Then obviously operating system thought that is very interactive, but operating system पता है ऐसे भी कुछ clever लोग होते हैं. So what he does, he told that in a queue you can stay maximum for 20 units of time. After that definitely you have to come back. So ऐसे वो cheating करके कितना तक जाएगा? 10 बार max. Yes or no? 1.9, 1.9, 1.9 करके 10 बार या 11 बार ऐसे आएगा. So after 11th time he has entering, come out, entering, come out, entering, come out. Then operating system says that you are very clever. You please come down to this. So there are 2 fixed unit of time he has decided. One is every job, those who are present in the lower queue, they will be come to the upper queue after this fixed unit of time. And because of this cleverness, the operating system also designed this algorithm in such a manner that after fixed certain unit of time, let's take 20 units of time, this job has to be come down to the lower. Again, this is also a fixed unit of time. Suppose here it is fixed 30. Even if you are cheating here also, after 30 units of time, up niche like this. Yes. So this is basically called as a multi-level queue schedule. Understood? So every job, so process again I'm saying because you are going to implement this queue using C programming language. वो आप नहीं करते हो, इसको assignment के हिसाब से आप कीजिए. So what you have to do, you prepare 4 queues and you try to generate a random jobs. Yes, random jobs. Jobs you have to generate, and every job, think that it has a 4 units. That is a CPU unit, IO unit, CPU unit, and IO unit. Every job. There is a P1, P2, P3, P4, P5 like this. And you prepare only 4 queues. So you have to now design that. This is also random number comes. Suppose it is 5 comes, then 7 comes, then 3 comes, then 2 comes. Every job has like this. So jobs are coming and they will be executed here. Then you have to design in such a manner that your program will be at last say that how the processes will be executed in which queue, how much time, and how, when they are moving to the next queue, when 50 units will be over, how they are moving to the upper queue. Okay, you can think of this. This is a very nice algorithm. Those who are good in coding, you please implement this one. If you have understood all the things, you have to design 4 queues. The queues here as an unlimited size. This queue, this queue, this queue are the unlimited size. Okay, but every queues has a quantum time of a 2, 4, 6, 8. Once you learn how to do the round robin algorithm, then you can apply this round robin here. So you have to apply a round robin algorithm. Once all the jobs will be finished here, you come here. Once all the jobs will be finished here, and how the jobs will become here? After a fixed period of time, one jobs are joining here. Okay, after a fixed period of time, one jobs will be. You take a random period. After random period, P2 is joining. After random period, P3 is joining. So you take an array of processes. Each process again has an array of a timing, and this timing is fixed. Timing is fixed means every process has only 4 works he has to do. Some CPU work, some IO work, some CPU work, some IO work, and one more you take a CPU work. Or you remove this, only prepare up to this. CPU, IO, and CPU. And these numbers are also getting a random. And I hope you know how to generate a random by random. One function is there by which you can generate this one. And by this way, you have to calculate when the process is joining, how they are entering, when they are coming. Right? So this is the idea which is mostly useful in this multi-level feedback. And this is the algorithm where you can satisfy the interactive processes, satisfy the non-interactive processes, satisfy the priority processes. Because based on the priority, first you enter. I am giving you all high priority to you because I am telling that first time when you come, you please join in the first room itself. But if you feel like that you are very lazy or heavy, you come down, again come down. But still after 50 units of time, I will give you a chance once again to come to the first queue where the CPU can solve it. If still you are lazy, again come down. And extra one thing you have to add, this clever rule. One should not cheat to this algorithm. By applying a fixed amount of time, after a fixed amount of time, a job even if it moves in, moves out in the same queue, but after this fixed unit of time, it has to come down to the next queue. Okay, so this is about this multi-level queue strategy. So next, I will start the most important topic one more, that is called as process synchronization. Once you finish
Sir, how will we implement that this thing? Sir, here we will make the 4 queues and we have to make that CPU also.
No, there is no CPU. You have to just feel that the CPU is giving you 2 units in this queue, 4 units in this queue, 4 units in this queue. In what sequence they are executing, you have to tell.
Sir, and we will follow the 2 as 2 seconds. That sleep.
2 are the 2 seconds. 2 are the 2 seconds. 2 here there is no second. 2 are the 2 unit time. Because you will not execute actually for the 2 units. You have to just prepare a sequence that which job will be executed in which queue for how much time.
Okay, sir.
Only this, because you don't think that यहाँ पर 5 unit CPU मतलब 5 second के बाद जाके next job execute होगा. Here there is no CPU is not given. You assume that if the CPU is given to this queues, in which sequence this process will be executed and when these processes are going to be completed. And before this also you can think, if more simplifies, if you want to do it, what you can do, you take a P1, P2, P3, P4, P5, like this you create 10 jobs. Each jobs you make a CPU time, IO time, and this CPU time. And these processes you consider arrival time. Okay, arrival time. So what time they are arriving? I think you can take a random data for all these 4 parameters. What is the arrival time? What is this first CPU time, IO time, again CPU time? Once you get it, you prepare a whole list that when each processes is going to be completed in which queue. By that, and you take a quantum time is like this 2, 4, 6, 8, and also you can consider what is the fixed amount of time for this queue, this queue, this queue, this queue, and when this all the queues element will be come back to the beginning queue. Here I have taken 50. You may consider something. Okay, by this design these things. I gave it to one first year student in some college. So he has 2 days he has implemented and give it to me. Yes, first year, only first semester student I was going somewhere and given this one. Within 2 days he has completed and give it to me. Yes, I hope you are, you better than him also. So if you are little confident in queue codings and these things, please implement. Don't reject. And next assignment, once you finish, I'll tell you, you have to look into XP6 is using currently which scheduling algorithm. How can you implement some round robin and priority in the XP6? Okay, that is you have to next plan. But first you have to give me the first assignment, then I'll give it the second. So next start with process synchronization. Very, very typical topic. People usually afraid of this one. Okay, but let's see. I'll try to explain. If you have any doubt in any point of time, please ask. I'll make a certain flow through which you can feel that as nothing is there in this particular topic. So what is process synchronization? Before going to the process synchronization, we have to know what is this process. Basically, the process here we are considering are of 2 types. Yes. So one is called as the independent process. And another one is called the cooperative process. What is an independent process? Means a process is said to be independent if it is not affected by anybody. If it is not affected any other process. Like if you can say, I have written a main program where A will be there, B will be there, and C equal to A plus B will be there. And since A and B are the local variables, C is also a local variable, there is no question of this process will be affected by somebody. But what this cooperating process basically says that, the cooperating process says that one process may affect another process. Process may be affected by another process. So how it is affected? So this can be affected if it is using some shared memory. This means if you can consider this is a process P1 and this is a process P2, if there is a equal to 2 and he is making A plus plus, he is making A equal to A minus 2, if same A is used by both the processes, means these two processes are cooperating. Because by this A, this may be affected, and by this A, this may be affected because both of them are using a common resource or the shared resource. Got my point? So if it is an independent process, we don't worry about anything. But if it is a cooperating processes, because of this sharedness or they are using a shared memory, that's why the problem comes into picture. Then what is the problem? Because of this shared memory, what is going to happen? We have seen one example that if I consider, I'll give you a problem, then we'll suppose there is a person P1 and there is a person P2. Both the persons are using a same account. Yes, this account has 500 rupees currently, and both are brothers. The brothers have a joint account and both are using the ATM card. And this fellow is staying in one city and this fellow is staying in another city. Both the person can enter their ATM card at the same time since they are staying in a different city. But both the ATM cards are related with the same account. Then what he does, he wants to withdraw some amount here and he wants to withdraw also some amount here. As I told, since both accounts belongs to the same bank and this is a single account, then there must be one function will be executed that is called as a withdraw amount. Yes, so withdraw amount, there will be some account number and some AMT. So this, when this person is also entering the ATM card, so here also same withdraw function will be executed. Withdraw amount where account number and some amount is done. Then what is written in this account withdraw function? Because this function is running in the server of the bank. The moment he is entered the ATM card, suppose he wants to withdraw 10 rupees. And he wants to withdraw here 30 rupees. Then what happens here? How will you withdraw? So inside this function of that program, it must be written that you get the current balance from this SC and get it as a int balance. Then you have to make that balance minus equal to AMT. Then you have to make a put balance. Put current balance will be same account with BL. Here also the same code has to be done. So you can say there is a int balance equal to get current balance, that is account. And since it is 30 rupees, so the balance is equal to minus equal to AMT. And again, this is a put current balance will be account, comma, that is balance. Yes. So these are the two codes which is run by two processes. Why it is a two processes? When this fellow is entering the ATM card is a machine. Machine means there is a program is running. And this program's work is to call this function of the server machine. This ATM's program's work is to call this function of the server machine. Means there are two processes. Both the processors try to execute this code to update this account balance. Because they are withdrawing 10 and 30 rupees. So after this 10 and 30 rupees, definitely it should be 460 rupees in the balance. But usually this balance may not be 460. How it is happening? Because since these are the two processes running in the same machine of the bank server, then what happens? The context switching is happening between the two processes because two processes are running simultaneously. So let's take, this is the first job executed, first line executed, then the second line, then third line, and then the fourth line. If it is executing in this manner, then what should be happening? Account, first account is 500, so it comes 500. Next statement executed this, account is still 500, this is become 500. Third statement is executed in this by the CPU of that server. So the amount is 10, this is 10 and this will be 30. Okay. So 10 is balance minus, this is 490. 490 will be updated in the account. Then it is coming here, amount is 30. 30 and balance is 500. 500 minus 30 is 470. And 470 is updated here. Now my last balance is becoming 470. But it should be 460 because he has already withdrawn 10 amount. He has already withdrawn 30 rupees amount. But still my balance is 470. So I always prefer this kind of bank where I deduct more amount, but my account balance is gradually increasing. So this is one way. Another way, the same thing if you can run in a different manner. Suppose this is become one statement, this is become two statement, This is become 3 statement and this is become 4 statement. Can you quickly tell me what should be the balance here?
490.
490. This is one. And another case is what? Suppose this whole thing will be executed first, then he will execute the second thing next. Then what should be the balance? 460. And what happens? By the order of this execution, the output gets changed. Yes or no? If I'm executing first this, second this, third this, fourth this, one result comes. First this, second this, third this, fourth this, another result comes. If first whole thing, second whole thing, then another result comes. My program is same, but in 2 different scenarios, 2 different output is coming. And those scenario is basically why? Because they are using the shared memory. Because of the shared memory, one problem comes here, that is called as inconsistency. Yes, because of whom? Because of the shared memory. Because of using the shared memory. And we did these things in last but one class. How it is happening? Because we did one, we have created T1 and a T2 2 threads, if you have remember correctly. I run a particular for loop where it is executed for 1 lakh times. And here there is a P++. I am expecting that the total should be 2 lakhs. But sometimes it is giving 14 lakh something, sorry, 1,14,000 something, 1,16,000 something, like this it is coming. Because what? Because both of them are using a global variable int p, where p will be shared to T1 and a T2. In the same manner, my account is single and this account is shared by both the processes, and that is become a shared resource. Since this shared resource is accessible by both the processes and both processes are running simultaneously, that's why the inconsistency comes into picture. So why this inconsistency comes? Because of these 2 things. What is that? One is, you can say, that is execute the simultaneously. Execute simultaneously, and plus what? They're using a common resource. Using a common resource. Are you getting my point? Yes, because of this inconsistency comes into picture. And this inconsistency is basically called as the race condition. Yes, so what is a race condition? The race condition is a scenario where more than one process use a resource simultaneously, and the final result depends upon the order in which this shared resource is accessed by these processes. Are you getting my point? Means what is saying? 2 things are very, very important. They are running simultaneously, because if they will not run simultaneously, there is no question. Why there is no question? Suppose you think this person and this person will be enter their ATM card at a different time. His brother is entering at 10 o'clock. He is entering at 9 o'clock. So after 9 o'clock, this process has completed. Then this process starts. Means though processes, even if they're using a common account, still there is no issue. Second, even if they will run simultaneously, but if they are not using any common resources, then also there is no issue. Why? Because let's say there are two processes. He is using a account called as 21 and he is using another account called as a 51. Then also there will be no issue at all. Because resources are same. Or you can say he is using a other bank's account and he is using a some other bank's account. Is there any problem comes even if both the processes will be run simultaneously? Never. So that's why what he's saying, it has to be simultaneously executed. At the same time, they have to use a common resources. Then only there is a chances of inconsistency. And this inconsistency will be represented by a rest condition. Then what is saying? It is a scenario where more than one processes uses a common resource. So you can say a common resource simultaneously. That is also important. And the final result is depending upon the order in which they are executing. As you have studied, if he is using this order 1, 2, then this 3, then 4, it will be 470 is the result. If he is following 1, 2, then this 3, then 4, then the result will be 490. If fully it is executed, then this will be executed, then it is become 470. Means the result is varying this. Then it is called as a rest condition. But do you like a rest condition? We never. Why? We don't want a different kinds of output will become when different times it will be executed. We want, since it is a program, always it has to be give the same output for the same kind of input. Then how to avoid this rest condition? Then it's saying to avoid this rest condition, a technique is called the synchronization. To avoid this rest condition, we need synchronization. Yes. Now the question comes, how can you do this synchronization? Okay, how to avoid it? Because take one small example so that you can relate how you can avoid this particular thing. So let's think this is our toilet. Yes. This is the toilet. This toilet is the common area. We have the family members, 1, 2, 3, 4 in every family, there are many family members. If since it is a common area, if all the family members are going to use the same toilet, then definitely there is a conflict will occur. He may be there, he will enter, or nobody is there, he is thinking that whether somebody is there or not. Even if 2 persons will be at a time enter into this, fighting them that I want to use this toilet, he will say that he wants to use this. So all kinds of inconsistency come into the picture. Then what he says, that is solved by a synchronization. Then how to solve it? They are saying, why don't you make this common area to be mutually exclusive? What does it mean, mutually exclusive? Means by this mutual exclusion, it will assure that only one person can enter into this common area at a time or use this common area at a time. If that is achieved, then my synchronization can be achieved. Which indirectly you can say that this particular synchronization can be achieved by applying the mutual exclusion. Mutual exclusion on the shared resources. Yes. So next class we'll study how we can apply this mutual exclusion on the shared resources. But most important thing, why we need a synchronization? The synchronization we need because of this. And we have already done one nice example of this P. If you have remembered. Have you remembered this P, how it was changing the values? Yes or no? Are you able to recall or not? Yes, that is the case. So that is basically called as inconsistency. And this inconsistency will be represented by a rest condition. A rest condition says that it will give a different output at a different scenario. How can you avoid it? That is a synchronization. How can you achieve this synchronization? He is saying दिस कॉमन एरिया को पूरा म्यूचुअल एक्सक्लूसिव कर लीजिए। म्यूचुअल एक्सक्लूसिव मतलब क्या है, अभी तक नेक्स्ट क्लास पढ़ेंगे। मतलब in area you can allow only one person to enter at a time, not two persons. So if it is, then definitely this will happen here, because once he has entered into this area, unless until he will come out, don't allow him to enter. Then it will be always gives 460. What you study. If this is fully executed, then it will start executing, then 460. But if it is partially executed, then it is partially executed, then there is a confusion of whether it is 470 or 490. Okay? Yes? Yes, sir. 1 minute. Yes, got it. Battery खत्म हो गया. Are you getting what is this one? So next class हम पढ़ेंगे how can you achieve the mutual exclusion and what is the code for writing this mutual exclusion and all this data. Okay, that's all today. Understood a little bit? Okay, then I am ending. Huh? Any question you can ask if you have any doubt. Otherwise, I'll end.
Hello, sir.
Please.
Sir, as the process is mutually exclusive, sir, so the process which will be executed will be decided on some priority basis, right? Right, like this will be executed this first, and then some other process will be executed, right, sir?
No, in which case? Here you are saying mutual exclusive case?
Yes, sir. Like, if you have to execute multiple tasks, so it will be decided on some priority basis that which task has
Yes,
to be
priority
performed.
basis, okay. On priority basis, first you decided that this will be executed.
Yes,
But
sir.
even if it is a priority basis, after that context switching will be happening or not?
Yes, sir.
Yes. Suppose I have given you, suppose just look into it, very nice point. Suppose a high priority has come. I allow him to enter into this and he has partially executing. After that, one more process comes which is higher than this and he wants to execute this one. Whether I'll allow him or not.
Yes,
As
sir.
per the
Because it is
priority
high
basis, I'll allow.
Yes, sir. Yes, yes, sir.
Yes. But mutual exclusion says that even if he is a higher priority, since a process has already entered into this common area, I will not allow him to enter into this area.
So the process with is under execution will be executed first, right?
Yes. If he has entered here. But it may happen like I have entered into this area. But a high priority jobs comes who does not want to enter here, rather to different jobs. Then we will allow him to enter there.
Okay,
But if
sir.
he wants to enter the same job, he will not allow. Okay?
Means
Yes,
that
sir.
it is a first come basis. The whoever gets the key will use it for a certain time
Whoever
Until
will
it-
be.
until
सही
he
बोले।
releases it.
Yes, sir, सही बोले। जो पहले तो मतलब अक्सर रिसीव किया है, he has to be complete, then only another person comes. That person may be how big, it doesn't matter a lot.
Okay, sir.
But that person will be affected. क्यों अफेक्ट करेगा बोलिए तो वो देखिए एक सिंपल सा एग्जांपल, सपोज मैं एक लो ग्रेड का गया हूं, कोई एक ऑफिस में मेरा काम है, मैं कोई क्लर्क को और किसी को पूछ रहा हूं कि यू प्लीज डू दिस माय वर्क. ओके, नाउ यू कैन अंडरस्टैंड दिस. डू दिस माय वर्क. ही इज डूइंग दिस वर्क एंड अज्यूम दैट दिस वर्क कैन बी डन एट ए टाइम बाय 2 पर्सन नहीं काम कर पाओगे. उसी टाइम पे मैं हाफ काम किया था, another higher standard employee has come into enter into that office. Since a high priority, वो क्लर्क खड़ा हो गया, वो बोला कि नहीं सर, बोलिए क्या काम करना है. And this higher standard employee or higher class employee has asking for the same job what I am doing that. Okay, doing that. But as for that job is concerned, it is mutually exclusive. It cannot be allowed to anybody unless until I leave that job. But मैं तो आधा काम किया हूँ, मैं बाहर नहीं आ पा रहा हूँ because I have to finish this work. But that person is higher than me. Then if that employee who is doing my work is the CPU, then the CPU is now standing and asking to whom? To the higher standard employee that बोलिए क्या काम कर सकता हूँ, वो बोल रहा है मुझे वो काम दीजिए, लेकिन CPU cannot release him because he is saying that that area is mutually exclusive. I cannot release him. Still he is asking. Still CPU is doing. Then what happens? The CPU is most of the time busy with talking with whom? To these higher standard people. Even if I am inside this area where partially I have executed, I cannot able to execute. Are you getting my point? So priority is there. Because of priority, he is getting a chance to talk with that employee. But the काम है, unless until I leave that work, this higher employee cannot take it. समझ पा रहे हो ना? हाँ, नेक्स्ट क्लास जब पढ़ेंगे एक एग्जाम्पल लेके, एक्सप्लेन. हाँ
सर, वो जब मीन्स जब वो टेलर वो एम्प्लॉय को बोलेगा कि मतलब मैं वो जॉब नहीं कर सकता, तो वो क्यू में पीछे चला जाएगा ना सर, और आपका जॉब कंटिन्यू हो जाएगा.
वो क्यों में पीछे चला जाएगा? ठीक है, वो चला जाएगा. भाई सही बोल. आप मैं यहाँ पर हूँ, सपोज P1 अभी काम कर रहा है, ये है टॉयलेट. सोचिए P1 टॉयलेट के अंदर है, ये आपका एम्प्लॉय है. यस, एक हायर एम्प्लॉय, एक हायर ऑफिसर हैज कम. सो ये बोल रहा है कि मैं जाना चाहता हूँ. ये एम्प्लॉय खड़ा हो गया, बोल रहा है कि नहीं 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 आप नहीं जा सकते हो बिकॉज दिस एरिया इज म्यूचुअली एक्सक्लूसिव, 2% कैनॉट एंटर. लेकिन वो चिल्ला रहा है. सो नाउ यू आर सेइंग दैट सर he will go to the queue and he will go to the queue, but immediately after few seconds again the CPU has to give it to him. Why? Because as per the scheduling rule is concerned, a high priority job should be executed first. Then मैं थोड़ा सा काम किया था, फिर एक इंटरप्ट आ गया. Why the interrupt has come? Because a high priority job is waiting in the ready queue. तो इसलिए क्या करते हैं उस टाइम पे, ये जो हाई प्रायोरिटी जॉब को क्यू में नहीं रखते, इसको बोलते हैं कि आप जाके सो जाओ, स्लीपिंग स्टेट में. आप अगर उसको क्यू में रखोगे वो तो चिल्लाएगा ना, वो बोलेगा मैं बड़ा आदमी हूं, मेरा काम कीजिए, मेरा काम कीजिए. बस चिल्ला रहा है को, ना ये काम कर रहा है, ना ये भी अंदर जा पा रहा है. बिकॉज इट इज लॉक्ड. अनलेस अंटिल वी विल ओपन फ्रॉम इनसाइड, नोबडी कैन एंटर. वो भी क्या करेगा, सीपीयू भी कुछ नहीं कर पा रहा है, क्योंकि सीपीयू का की उसको दे दिया है. This he has locked from inside. Even if he चिल्ला रहा है फिर भी नहीं कर पा रहे. So चिल्लाने से क्या मिलता है? When he is shouting more and more, he is getting disturbed. Neither he is giving time to him, nor he is doing the proper work. Only इसका बात सुन रहा है. बात सुनने से कुछ फायदा नहीं है, काम तो यहाँ पर है. Then इसको क्या करेगा? वो बोल रहा है कि don't stay in the queue. Since you are waiting for this area and area is mutually exclusive, why don't you sleep in the restroom for a certain time? This restroom is different. Sleep in the restroom. So you sleep it. Whenever he will be free, I'll call you. Please enter. Okay. पूरा जैसे हम नॉर्मल वे में काम करते हैं, ऐसे ही वो कोई बनाया है OS को. Okay. Fine. That's it. थोड़ा समझ में आया?
Yes, sir.
यस सर.
Good. Okay, I'm ending. Huh?